Energy moves the world. It enables humanity's great advancements and drives societies toward growth and improved quality of life. But how can we ensure this happens sustainably when over 660 million people worldwide still lack access to energy? When so many rely on highly polluting fossil fuels that directly contribute to global warming? Despite investments in renewable energy, the intermittency of these sources remains a challenge. The combined use of generators and batteries to ensure a minimum power supply in isolated areas is necessary. This solution significantly increases the cost of any project due to high operational costs and logistics heavily dependent on fossil fuels, with a limited and unsustainable life cycle. As a result, these hybrid systems are still highly polluting, expensive, logistically challenging, and fail to provide high-quality energy. And that's where we focus our energy, enhancing the reliable delivery of power by strengthening the clean energy grid through an innovative project by EcoSoma, a solution that promises to revolutionize the renewable energy market. The Intelligent Control System, SIC PVDG, is our innovative solution. When connected to hybrid systems composed of photovoltaic generators and combustion generators, it will mitigate system fluctuations, drastically reducing fossil fuel consumption and greenhouse gas emissions. It will be the first device on the market capable of increasing the penetration of photovoltaic generation to 70% in hybrid systems, compared to the current limit of 30%. We're talking about providing cleaner, more accessible energy, as it will also eliminate the need for extra generators and large battery banks. The result of this groundbreaking technology? A higher supply of clean, quality energy with a 15.13% to 30% reduction in fossil fuel consumption and greenhouse gas emissions. It will be a universal device, able to operate with any combination of hybrid energy generation systems. SIC will ensure operational efficiency by itself, minimizing environmental impact and enabling the hybridization of existing systems. Given its flexibility and versatile application, SIC has immense global potential, both economically and environmentally. Approximately 2.6 billion people worldwide depend on highly polluting fuels for power generation. Fossil fuels account for 60% of the electricity generated globally, leading to a significant increase in greenhouse gas emissions. In India, 70 million people lack access to reliable electricity. In Nigeria, 90 million people rely on fossil fuels for power generation. The potential impact of SIC technology in various global scenarios can be exemplified by a few cases. In Canada, expanding the electrical infrastructure in isolated communities is challenging. The country consumes approximately 88 million liters of diesel annually to supply these regions. In this scenario, adopting SIC has the potential to generate savings of $11 million annually in diesel consumption, alongside a reduction of approximately 28,000 to 30,000 tons of greenhouse gas emissions. In Brazil's isolated communities in the Amazon, 80 million liters of diesel are consumed annually, emitting 256,000 tons of greenhouse gases. Installing SIC could result in approximate savings of $13 million annually in diesel consumption, as well as a reduction of about 34,286 to 38,732 tons of greenhouse gas emissions each year. Desalination is a crucial process for providing water in countries such as the Bahamas, Maldives, and Malta. England and Australia are also investing in desalination to ensure greater security in their supply. Considering that the largest cost involved in desalination is electricity, implementing hybrid systems with SIC has the potential to generate significant cost reductions and environmental impact. Other markets, such as the Russian Federation, Colombia, and the United States, are seeing significant renewable energy expansion, offering opportunities for integrating Sic PVDG to increase the supply of clean, reliable energy. This innovative technology can drive the entire energy generation sector in the global market. In an era where alignment with global SDG goals for a more sustainable future becomes a relevant differentiator for economic players, Sic has a broad market reach, serving those who lack access to the electrical grid, seek greater reliability in energy supply, already use hybrid systems and want to reduce costs and increase productivity, are interested in adopting renewable energy to optimize the social and environmental impact of their actions. Sic will create exceptional market opportunities as it will demand new equipment and services, driving innovation in the industry. Energy generation equipment manufacturers can produce Sic or integrate it as an embedded solution, adding value to their products. As a cheaper and more versatile technology, it will help governments meet their obligations, provide power to isolated areas, deliver quality energy for activities such as extractivism and agribusiness, boost productivity in the industrial sector, and ensure the continuity of services in hospitals and schools. Additionally, the project should drive the adoption of solar energy, meet local demands, and reduce costs in hybrid generation systems. Sic offers the best payback on the market, with a return on investment between 1.7 and 3.5 years. It delivers 150% more fuel savings than the competition, with far fewer greenhouse gas emissions. The installation project is simple. Carbon credit trading is facilitated by online measurement software and updates. Our business model is renewable energy as a service because we want to democratize access, ensuring sustainability and recurring income. By renting our product, we expect to grow alongside our partners, expand commercial reach, and guarantee a circular economy. To make this project a reality, EcoSoma has a multidisciplinary team of experts in energy efficiency, as well as the entire infrastructure to manage the project. We have support from Embrapi, and Sic PVDG is being developed at the Smart Grids Institute at UFSM, which boasts some of the world's top researchers in power electronics and control. For additional scientific backing, we have CTech Soft Soul, further enhancing the capacity for development, testing, and validation of the necessary software. For business development, we also rely on TechnoPook, an ecosystem that involves companies, research centers, startups, and organizations. The project is patented, has been tested in a virtual environment, and began execution in 2024 with the setup of the proof of concept. The prototype is expected to be ready and tested in a laboratory environment by August 2025. Also, in 2025, the equipment will be tested in a real environment, with commercialization expected to begin in early 2026. Sic PVDG can bring cleaner energy to where it's most needed and transform lives through light, information, and opportunity. Join us in turning sustainable development into positive results for organizations, communities, and people.